Hello everyone. In today's video we shall know about the amines. So the general formula of amines will be the like for primary amine for secondary amine it's an R2NH, tertiary R amine, alkyl amine. Secondary amine is called as an N-alkyl amine. Tertiary amine is known as an N-N dialkyl. So next we shall look into the preparations. Reduction of cyanide groups gives an primary amine. Reduction of isocyanide groups give an secondary. So primary amine will be formed of cyanide group. Isocyanide or reduction gives an secondary amine. So next, reduction of cyanide by sodium in ethanol. So reduction of cyanide by sodium in ethanol is called as a Mendes reaction or Mendes reduction reaction. It's known as a Mendes reaction or Mendes reduction, where reduction of cyanides by sodium in the ethanol is called the Mendes reaction. So next preparation is from reduction of nitro compounds, where reduction of nitro compound gives an primary amine, whereas an aniline or an primary aromatic amine, where primary aromatic amine is prepared by the reduction of nitrobenzene. So next, by the reduction of amide groups gives an primary amine, and another next reaction is very important. It's nothing but the reduction of aldoxime and the ketoxime. So reduction of aldoxime, the formula will be RCH double bond NOH is known as an aldoxime. That on reduction with an sodium in alcohol gives an primary amine. Same thing, whereas ketoxime on reduction gives an primary amine. So LiAlH4, it's an reducing agent. Okay, next reaction will be the Hoffman bromide reduction reaction, where amide group on with an bromine water gives an primary amine. So next on ammonolysis. This reaction is known as an ammonolysis. Where alkyl halide is reacting with an ammonia at 373 Kelvin gives an primary amine. Next, primary amine on reacting with an alkyl halide gives an secondary amine. Further, on addition with an alkyl halide gives an tertiary quaternary ammonium salt will be formed. So when ammonia is in the excess, primary amine will be the main product. When ammonia will be reacted with an alkyl halide in the excess, gives an primary amine, whereas alkyl halide is in excess, then quaternary ammonium salt R4NX, quaternary ammonium salt will be the main product. So next reaction will be aldehyde reacting with ammonia gives an primary amine. Next, ketone reacting with an ammonia gives an secondary amine. The next preparation method will be a Gabriel phthalimide reaction, where a phthalimide, this is an phthalimide. Phthalimide reacting with an alcoholic KOH gives an N-alkyl phthalimide, and that formed N-alkyl phthalimide on hydrolysis H2O gives an primary amine and a phthalic acid. So, and this Gabriel phthalimide reaction is used for the preparation of primary aliphatic amines only. Okay, na? So used only for the preparation of primary aliphatic amines, but not the primary aryl halides. Why? Because the primary or the aryl halides do not undergo nucleophilic substitution reaction. So the aryl halides, they do not undergo nucleophilic substitution reaction. So this is the reason only the Gabriel phthalimide can be prepared for primary aliphatic amines. So next, Grignard reagent. Grignard reagent reacting with an chloroamine gives an primary amine. Next, last preparation will be where carboxylic acid is reacting with an hydroxide in the presence of SO4, a primary amine. be obtained. So these are the important preparations of amines. So next we shall look into the properties where amines are basic in nature due to the presence of lone pair of electrons on the nitrogen atom. Aliphatic amines are stronger than the aromatic amines. Next, basicity of amines depends on the plus I inductive effect of alkyl group, hydration energy and the steric factor. So higher the value of Kb or lower the value of pKb, stronger will be the amines. So higher the value of Kb or lower the value of pKb, stronger will be the amines. So next, if the electron donating groups increases the basicity of the amines, same way electron withdrawing group decreases the basicity of the amines. So next will be the some chemical properties or chemical reactions. Okay, where primary amine is reacted with an aldehyde in the presence of an acid gives an anil. Anil is also known as an Schiff's base. Even primary amine reacting with an ketone also gives an anil. Where Schiff base or anil on catalytic reduction gives an secondary amine. When the anil compound is undergo a reduction process in the presence of a catalyst, it gives an secondary amines. So next, another important reaction will be primary amine reacting with an Grignard reagent gives an alkane. So next, amines reacting with an HNO2, where aliphatic amine when it HNO2 gives an alcohol. Primary aromatic amine reacting with an HNO2 gives an diazonium salt. Next, secondary amines. Both aliphatic and aromatic secondary amines when it reacted with an HNO2 gives an nitrosoamine. Tertiary amine, aliphatic tertiary amine when it reacts with an HNO2 gives an nitrate compound which will get soluble. Whereas tertiary aromatic amines reacting with an HNO2 gives an nitrosoamine. So next will be the oxidation reaction of amines, where primary amines on oxidizing with an KMnO4 gives an aldehyde group, where primary amine reacts with an H2SO5. H2SO5 is also known as a Carros acid. It is also called as a Carros acid, H2SO5. So when primary amine is reacted with an Carros acid, it gives an N-alkyl hydroxyl amine. Secondary amine on oxidation with KMnO4 gives an tetraalkyl hydrazine, where hydrazine compound will be formed, where secondary amines reacting with an H2SO5 gives an N-hydroxyl dialkyl amine. N-hydroxyl dialkyl amine will be the product when secondary amine on oxidation with H2SO4. Taken place. Why tertiary amine does not go oxidation? Because due to absence of hydrogen molecule, hydrogen. So next, tertiary amine reacting with an Carros acid gives an amine oxide, whereas aromatic amines like aniline on oxidation gives an benzoquinone, and when primary aromatic amine reacting with an hydrogen peroxide along with the Carros acid gives an nitrosobenzene. So next reaction, where amine reacting with an COCl, it's also known as an benzolation or on benzolation, where amine on benzolation along with the presence of an NaOH gives an RNHCOC6H5. This reaction is also known as Scott-Beumann reaction. What happens in this reaction? Where amine will get reacts with an benzene along with an acetyl group. So that's why we call it as it's a benzylation. And next reaction where primary amine reacting with an chloroform along with an KOH, it is an carbylamine reaction. It's a carbylamine reaction. So next, the halogenation reaction of amines. So when amine is reacted with an excess of bromine water, we get an 2,4,6 tribromoaniline, which will be the white precipitate. It will be in the white precipitate form. So but to get the monosubstituted products, only to get the monosubstituted products, aniline has to get acetyled first. So which means aniline should undergo the acetylation reaction in order to get the monosubstituted product. So next will be the sulfonation, where sulfonation aniline is reacted with an H2SO4 gives an sulfonilic acid, same as nitration gives an M-nitroaniline. M-nitroaniline means where the aniline group will be in the meta position of the nitro compound. So next, distinguish of primary, secondary and tertiary amines. Primary, secondary and tertiary amines. You already know about the Innsberg reagent. It's also benzene sulfonyl chloride C6H5SO2Cl will be the Innsberg reagent. So when primary amine is reacted with an Innsberg reagent, it gets clear solution. It gives a clear solution, which means it will get soluble in the Innsberg reagent, whereas secondary amines show the insolubility and tertiary amine does not show any reaction. Tertiary amine does not show any reaction. So next, another important method to distinguish the primary, secondary and tertiary amine will be the Hoffman's method, in which diethyl oxalate will be used. Diethyl oxalate will be used in the Hoffman's method, where primary amine, when it reacts with an diethyl oxalate, it forms into a crystalline solid. Where secondary amines will be in the liquid state, and tertiary amine same, do not show any reaction with an Hoffman's reagent like diethyl oxalate. So next will be the reactions of diazonium salt. So first reaction where diazonium salt is reacting with an H3PO2 along with an cuprous chloride, will get an benzene as the main product. Diazonium salt reacting with an the ethanol, again benzene will be formed. Next diazonium salt reacting with an HCOOH with an formic acid. HCOOH with an formic acid gives an benzene. And next will be the Sandmeyer reaction, Gattermann's reaction. You will be known, where in the Sandmeyer reaction, important to be remember will be you will be using the cuprous halide. But in Gattermann reaction only you will be reacting with the copper. There will be no cuprous halide will be used in the Gattermann reaction. So next, diazonium salt reacting with an HNO2 along with an cuprous oxide gives an nitrobenzene. Next, diazonium salt with an H2SO4 along with the water gives an phenol. Next, diazonium salt reacting with an CH3OH with a methanol gives an hanisol. IUPAC name of hanisol will be the methyl phenyl ether. Methyl phenyl ether will be the common name. IUPAC name will be like methoxybenzene. So next, diazonium salt reacting with an ethanol along with the copper metal gives an diphenyl. Next, another important reaction when diazonium salt is reacting with an H2S. When diazonium salt is reacting with an H2S or along with an ethanol. Another important reaction will be diazonium salt reacting with an H2S or along with an potassium xanthate. Potassium xanthate formula will be C2H5OCS, and S and K will be there along with the potassium xanthate. I will write it clearly in the next to the reaction. C2H5O CS along with an sulfide and potassium. So this is called as a potassium xanthate. Potassium xanthate gives an thiophenol. Gives an thiophenol. So next, diazonium salt reacting with an acetic acid gives an methyl benzoate. Next, diazonium salt reacting with an phenol or an aniline. Both these two reactions will be the coupling reactions. So these are the important reactions and points to be remembered for your Kcet examination from the amines chapter. Thank you all.